Good morning, good afternoon, good evening, folks. Welcome to this webinar today. We're going to talk about building and operating cloud platforms at the edge. I'm Vamsi, Chief Strategist of Platform 9 Systems, and Peter Frey, my colleague, is on the bridge as well. And we'll get an introductions in a quick minute. But before we get started, just wanted to mention a few key points. Number one, the focus today would be on architectural, infrastructure, and application considerations across different industry verticals and in terms of deploying edge workloads. So we won't be spending a lot of time talking about what the edge is. We've already done that in previous webinars, and there's a lot of downloads and blog links that are going to be made available after the fact today that you can read up on the topic. The other fact is that today we're going to be focused on the edge challenge and talk about some of those design considerations. But the webinar, for those of you who are not able to join the webinar, this would be made available even after the fact, so you can download it. Please feel free to share it with your coworkers and your friends through all the social channels, Twitter, Facebooks, so on and so forth. And finally, we'd love to hear from you during Trita's presentation. So if you have a question for either Peter or myself, please feel free to send it through the Ask a Question tab or the chat tab at the bottom. We've got people here at Platform 9 monitoring the chat window to be able to, intercept those questions and then talk through them. So again, as participants trickle in slowly, I'd like to kick things off by welcoming Peter, and then let's start with some introductions, and then we'll start getting down to the agenda and the technology itself. Peter?
Yeah, hi, Vamsi. Real quick, I think we should do the poll, get that started real quick, and then we'll do introductions as we're waiting for that to populate. Kamesh, do you have a poll for us today?
Yes, I just launched it.
Thank you. Okay, great. Well, that's starting off. Hi, everybody. My name is Peter Frey. I'm a field CTO here at Platform 9. I also run our worldwide pre-sales engineering group and our worldwide customer success teams. I'm coming to you today from sunny Florida, and we're getting rain as well. So I think it's happening a lot across the country. And I've been at Platform 9 for 2.5 years now. And prior to that, I was at another container startup called Apsera. And so I've got a lot of industry experience when it comes to looking about containerization, how to do containerization, how you implement it in your organization. And most recently, we've been talking to quite a few telcos and edge companies that are very interested in starting to take Kubernetes and or virtualization out to the edge. And so I think that's what we're going to talk about today. Vamsi.
Thanks, Peter. So hi, everybody. Vamsi here. I'm the Chief of Strategy at Platform 9 Systems. Past roles, primarily in open source, but prior to that, I did spend a few years at Siemens Medical Solutions building healthcare protocol systems and healthcare information systems. But primarily Red Hat, where I was Chief Architect of Financial Services, and had a small hand to play in some of the original cloud technology out of Red Hat, CloudForms, OpenStack, and then OpenShift. And then moved over to Hortonworks, where I led the industry vertical for global banking. So again, as Peter mentioned, I spend a lot of time talking to, I think it's been a theme for the last 6 months of Platform 9, a lot of telcos. And we're basically doing a lot of work around edge computing, around delivery of applications that are closest to the customer, whether it's a sell side, whether it's a CDN or a retail store or a manufacturing shop floor. But again, glad to distill all those learnings from these journeys and to bring them to you today. So again, there's a poll that you're seeing on your screen, and Peter's going to sum up the results of the poll in a few minutes, but please feel free to vote on these questions. And really the idea is that as we get the answers to these 4 questions, we can kind of understand where you are in your Kubernetes journey, and where you are with overall managing containers and Kubernetes, because we think that at the edge, it's a completely different conversation now with containerization as opposed to VMs that ruled the roost for a decade. So again, Peter, let me turn it over to you if you want to talk about the poll or cover that.
Yeah, sounds good. I'm going to take a chance here, and I'm going to end the poll. Let's go over the results. So with our poll, this is useful for us because it helps us tailor our message to our attendees. And the first question was, where are you in your Kubernetes journey? And it looks like 67% of the respondents said they are just getting started. And I talk to enterprises all over the country, and some are more advanced than others, but in general, most organizations are really trying to figure out how are we going to start with Kubernetes? Where do we want to start? Who do we need to train? SREs and DevOps and all of those people. And, how do I get my app containerized? And so the just getting started answer kind of makes sense to me. The second question was, where do you plan to run on Kubernetes? This was interesting to me. 58% said that they were going to do it on-prem. I think that's a trend, but most of the time I see most of our respondents come in with a public cloud because they all seem to get started there in the public cloud. And then the on-prem is where I think people are trending to move towards because of either competition with the big cloud providers or cost of the big cloud providers. So I think that's an interesting thing that we're starting to see. It's switching to more of an on-prem focus. The third question was, what was your biggest challenge in managing Kubernetes? And that answer comes up with maintaining high availability and reliability of clusters. And I think that's absolutely a fair answer for most every organization that goes down the path. When an organization adopts Kubernetes and they're on that Kubernetes journey, they are spending a lot of time, figuring out, how do I get this production ready? If it breaks, who do I call? And when Kubernetes breaks, it breaks in subtle ways. The app could be causing things, consuming memory, causing worker nodes to go offline, and you have to figure out what's happening in that Kubernetes cluster, and it's definitely a challenge for quite a lot of people. And then the fourth question was, the third one was, what was your biggest challenge with managing it? And the fourth question was, how do you plan to manage Kubernetes? And it looks like the majority of our respondents today are going with the self-managed open source distributions. So they're going to do the DIY approach. Vamsi, any thoughts on companies going down that DIY path?
Yeah, Peter. So as you know, we watch them do that with affection every week, right? As we see people building out their containerization platforms. Again, one of the things is that most enterprises are still getting started, as I think the data is fairly standard, about 67% on this call, but it's in reality up to 70 plus. The point is that when you start with Kubernetes and either you're using an open source version or you're using a distribution that's provided by the likes of Red Hat or Pivotal or whatever have you, the majority of the work is just an undifferentiated heavy lifting, right? It's all setting up the platform. It's identifying what servers you're going to run this on and understanding what choices you're making for the networking, for the storage layer, and how you're going to do your DevOps sort of thing. So once that gets done, the biggest cost you're going to incur is the day two operations, right? And on most cities in the United States and in Western Europe, you're probably looking at fully burdened cost of $200,000 per Kubernetes head. So yeah, that's something we run into quite a bit. But the question that enterprise leaders have to ask themselves is, where's the value in the business? Is it in just running Kubernetes clusters and managing them? Or is it helping lines of business write cool, relevant applications that are doing whatever your vertical does? Better supply chain, better order management, better customer onboarding, so you could drive incremental revenue. So yeah, but it doesn't surprise me, but I think I've seen quite a few failures where folks have run their own Kubernetes distros, or they've built out massive operations teams, and the ROI just isn't there from either a vendor or even from an open source standpoint. Do you agree?
I completely agree. Yep, I think that's one of the biggest challenges with Kubernetes. So well stated, Vamsi. So beware, if you're going down the DIY path, it is a challenge. Pick your apps carefully. Today we've got a prize, which I'm happy to announce. We're giving away a Lego set, I guess a Saturn V Lego set. Looks pretty cool. We'll give it away at the end of the webinar. You must be present and online at the end of the webinar to win. So we will pick somebody at random from the list, and then they'll get the webinar team here will help you. We'll get your contact information, and then send you the prize. Okay. So the goals for the webinar today, Vamsi.
Thanks, Peter. So what we're going to do today is basically talk through some use case in edge computing. And we're going to focus on telco, retail, and service provider verticals. But just keep in mind that when you talk about an edge, there are many edges. So what edge are we talking about? And where are you going to put that edge? Or what defines an edge for your industry dictates the architecture you want to run ultimately, right? So that varies from vertical to vertical. And one of the things we're doing in here at Platform 9 is as we talk to customers, as we go through our implementations and we mature in this space, we're going to put a whole lot of thought leadership out there. And we'll have webinars and white papers for all of these different verticals you're seeing out there. So we'll talk about that. So the topology of edge computing is what we'd like to spend a few minutes on. And different folks have spoken about this, but I do like a Gartner slide that I've reproduced with permission. So we'll talk about that. We'll talk about the fact that there's different edges or a topology of edge landscape here. And depending on where you want to be in that space, that'll drive what kind of form factor of devices you can put in and what automation you can bring in. And then we'll jump to the meat of the presentation, which is around the key technical challenges. So there's 6 unique technical challenges when you think of architecting edge clouds and edge applications that the average enterprise cloud architect or leader, she or he hasn't thought through. And these complexities are introduced by edges. But again, we feel at Platform 9 that the edge is no different from the core in a lot of ways in terms of how you look at workloads. And as you have developers that want a good experience, it shouldn't really have to matter to them whether they're building a 3-tier application that is going to do customer onboarding, that is deployed in your centralized data center, or if it's a AI ML driven application that works on a handheld device or a small or is in a car that is doing that. So the definition of edge itself is different, but again, architecturally, we'll talk about what these challenges are. And again, at Platform 9, our architecture approach, our approach to the technology itself is gotten rave reviews as well as increasing customer adoption. So we'll talk through how we maintain an open source heart, but innovate around the platform to provide you with solutions to these challenges. And then, we'll have some conclusions, and then we'll open the floor up for questions. But that's a core idea. So talking about edge clouds in the industry and what these are, right? Gartner released a report, and this is fairly consistent with the IDC will tell you, Forrester will tell you. By 2025, 3/4 of enterprise data is going to be created outside the data center. So it's going to be, not just a person sitting at a e-commerce app and ordering stuff from home, but also people interacting with your product or your application. We'll talk about what those are. That could be somebody walking to a retail bank. That could be somebody using a telco's 5G capability. It could be somebody that walks into a retail store and they're doing some operation there, or somebody even in a connected car, right? So we'll talk about what these use cases are, but the idea is that edge is going to start taking off more and more every year. And you as enterprise architects, IT and business leaders should have a strategy for a platform you're currently bringing in-house at this point, or developing or building, as to how that would play with the edge. So with that in mind, let's talk through some use cases in terms of what enterprise leaders are doing across different industry verticals. So obviously 5G and telco are number one, right? So telcos in all tier 1 telcos, pretty much in all advanced countries, in developed countries, are the early adopters of the edge computing paradigm, and the market operators are following. And then from a telco standpoint, a lot of interest in taking their virtualized networks And with 5G, they're kind of leading the charge and going to an edge deployment, edge compute deployment. So there's a variety of players we're working with in the industry, and hopefully in the next few weeks we'll announce some case studies, so on and so forth. But again, the key trend is that the software architecture that is hosting what they call the VNFs, which is the virtualized network functions, are moving from your classical data center VM-based architecture to basically an edge computing bare metal server that is running containers. So we're doing a lot of work at Platform 9, not just in NFV, SDN related initiatives, but also in areas like vRAN, and to support things such as cellular traffic management, a lot of VR, AR, gaming, video streaming, so on and so forth. So again, the other trend we're noticing is that a lot of telcos and other real estate operators are deploying edge sites in urban centers, and they're then deploying servers on these small footprint devices, and that's what's driving a lot of the edge adoption. And then,
Hey,
yep, Peter.
Hey, Vamsi, some of those edges aren't static edges, right, as well, right? I think some of the people we've been talking to lately are having dynamic type edge locations that maybe stand up to during a football game or a baseball game, and where they want to add additional 5G capacity during an event of some sort, and so they stand these things up. They put up a VRAN in a stadium. They then spin up a Kubernetes cluster, but then they turn it down when they're done, right? What are you seeing in that space? I mean, they're pushing Kubernetes out to the edge. They're running network function virtualizations out there at the edge to support these kind of events. Is that a trend where we're starting to see kind of these dynamic edge locations spinning up and spinning down?
No, absolutely, Peter. So that in my mind is taking place in two different forms, right? Number one, cell towers are being used as a way of spinning up capacity and spinning them up during peak when they expect peak traffic, such as a sporting event. But also the other trend is that what cable hubs are present, what head ends are present, a lot of cable companies are transferring them into small data centers. And that is being used to then, commercialize workloads, right? So they're going to put workloads there just in time, and then have the entire operation of that automated. And that's something we'll talk about. But no, good point. The fact is that, the edge itself can be a very dynamic thing. I've seen a couple of operators that we're working with where they want to basically set up a mobile edge, which can be, basically servers that are racks of servers that are just being brought in there for an event. And then once that's done, it moves, or, they shut it down, right? So again, depending on where revenue is being generated, folks are being very, very tactical, but very opportunistic about pushing workloads to the endpoint and then driving that and taking that customer traffic, the digital traffic. So good point. Yeah. So to that other end, manufacturing logistics, obviously automation of remote machine tasks, and then really trying to do more with automated, analytics and visualizing of equipment using drones in some cases, as opposed to, sending people out to remote sites, right? Which isn't exactly the cheapest thing. And then finally, with the COVID situation, healthcare, right? Are we doing a good job as a health industry, as a pharma industry, to be able to get population health metrics, to be able to to be able to optimize drug inventory. So we're working with a couple of providers, tech providers in this space, and their servers and their workloads are being generated as an appliance, delivered as an appliance, and created as a one, which is an x86 server running, OpenStack and Kubernetes and some local data storage. But again, the idea is that you want to be able to automate a lot of the onboarding as well as the lifecycle management and the upgrades to these workloads running on the sets of devices. So again, Peter, any points on these before we move on?
I think you covered it quite well. Yeah.
Perfect. So one of the things we spend a lot of time talking about is the topology of edge clouds, right? So edge as itself is a very umbrella term. What is a edge? Is it a thick edge or a thin edge, or what part of the digital supply chain does the edge sit? So if you kind of look at it from an endpoint standpoint, at the bottom you've got the consumer that's on their mobile device or whatever have you. So you could call that a device edge. And in verticals like cable companies or manufacturing or power and energy utilities, you've got millions of small devices, right? Which could be anything from smartphones to wearables to sensors or actuators, which are basically gathering a lot of data. And then the gateway edge is really where there's a server class machine or a PC class machine, which is able to gather all of this data and to essentially bring it together. And then that data is sent over to compute edge. Compute edge really is where you're maybe operating at a 25 to 50 millisecond latency, not in a data center, but it's close to the customer. Now, a lot of shops in telco would call the CDN edge the compute edge, and that's perfectly fine too. So again, latency is from 25 milliseconds onwards to 50, but they're running server class machines. Often they're running 6 to 12 servers. And sometimes these servers are repurposed from existing CDN use cases. And then again, the data then gets sent to the local data center and then the regional data center or to the global data center. Now, depending on the complexity of the business you're in, depending on the maturity of the technology you run, you could basically collapse these edges into, three parts, into three logical edges or four logical edges. That really is an open interpretation. But the idea is that depending on where you run and where your workloads run, there's different things to keep in mind in terms of how thick or thin you want the edge to be. So we do a lot of work at thin edges, which is just a complete stripped down operating system running on a 4 CPU handheld device that is running Kubernetes. That's one use case we run into a lot. And we actually do have a global customer running that in casual dining chains. But we also have customers that are at the CDN edge, and they're basically running streaming applications. And then we have customers at the local data center edge, and we have customers at the metro edge as well. So again, the choice of what technology components run in each of these edges really depends on the app and what you're running there. But one of the things we want to talk about is the ability of the platform to handle all of these configurations. So Peter, any comments about this before we move into challenges of edge computing?
Yeah, I've got a question for you actually.
Sure.
We were talking to a telco on Monday or Tuesday this week, and they were saying that they wanted 5 to 10 milliseconds latency from the event or whatever it is they were monitoring. Why was that so critical to them?
Yeah, I think one of the cool things you're going to start seeing more and more in telco is around the containerization of essential network functions. So what are known as CNFs. The idea is that workloads, especially things like the radio workloads, are all going to be running, the ORAN workloads are all going to be running right at the cell site. What that means is from the time they're basically interacting with a physical device endpoint, right, which is a mobile phone. And when a user wants an immersive experience, if it's an AR, VR app, or it's a streaming data app, streaming video app, the user is going to basically be at such a close proximity to the device and to the cell tower that literally every millisecond that they can shave off of performance is gold, right? In terms of the keeping that viewer sticky and driving a better outcome from a business standpoint. So use cases there are spanning everything from streaming to radio workloads to URL rewriting, security, so on and so forth, and running AI-based models. But the idea is that with a use case like that, you're so close to the customer that you're practically a second hop. So latency just becomes a game of milliseconds. So, which is why they've got very stringent requirements in terms of the ability to work on a bare metal server and to support specific innovation in how we do our networking and our runtime compute. What bells and whistles are there to tune better performance out of the compute.
Awesome.
Perfect.
So why is this challenging?
No, so for 6 obvious reasons, right? Number one, it's all low touch game. So back in the days of VMs, or still in the days of VMs, we've all got these metrics in terms of VMs to number of operators. The number one metric in which you'll know your cloud is running or it's going to fail is your VM to admin ratio has got to be super high. In that, obviously, most enterprises are not going to get to the level of a Google or a Facebook. They're not going to be a real, or Amazon. They're going to be not going to be web scale. But still, you want to be able to drive, at least 5,000 VMs to one admin, right, at a minimum. And now with pods, that ratio takes off. You want the low touch model, and because every person you add to your teams that are just running around carrying and tending to servers, you're basically taking those dollars away from the business. So again, the number one challenge here is the low touch challenge. And what that also means is that the traditional model of data center management doesn't work, because you're going to have a large degree of sites that are distributed. They all have latency challenges. And if you have to grow horizontally, your people teams with the number of sites that you have, that model just simply falls apart, right? So data center management, the data center model doesn't work. The third is, at times you'll maybe have servers running in far off corners of the world. You're not going to have experienced on technical staff. I mean, it's just impractical from a cost and from a ease of usage and agility standpoint. So you want to be able to have all the automation built into the edge platform so that it's extremely easy for even a non-technical person at the edge to perform maintenance. And in most cases, you do want to do all of this remote. Fourth, you need software capabilities, right? You basically you are going to run a mix of VMs, you're going to run a mix of bare metal and containers. You want to be able to span all of these different workloads at the edge. Number four, you can't outsource to a public cloud, right? Number one in that, and 1A is that cost. Public clouds are not designed to run humongous scale, and we see many a customer breaking their budgets for public cloud deployment. But 1B, latency itself is a challenge. Every time your user calls out at the edge, you're not going to be able to go out, make a round trip call to the public cloud and come back, especially for workloads such as radio. You're going to introduce a lot of bottlenecks in terms of performance. And number six, let's not forget the developers. Your DevOps teams are going to be out there, people writing code in Java, Python, Scala, whatever language, floats their boat. But the point is, they want to be able to push their updates incrementally to the edge, and they want to be able to do that at the time that they've done their development. So one retailer customer that Peter and I working with, they've got 250 stores across the country. Obviously with COVID, it's a bit of a question mark on when they can restart operations. But the idea is that their number one pain point is that they want to do all of these remote things, but their developers were going to be able to push their updates out without having to depend on operations teams to do that, and just push updates out to those edge locations or those store locations where people, want the greatest and the best fashions, like in New York City or San Francisco. So Peter, anything to add to this?
Yeah, I think, if you start combining the things that you're seeing here that make it a challenge, you start thinking of little to no staff, right? I think we should be able to manage edge locations with 0 people, other than the guy that takes the server out of the box, plugs the red cord into the red cord and the power cord into the power supply, and turns this puppy on. I don't think there should be any touch by any people to stand up an edge location beyond that. And we're starting to see that not only in the telco edges, but retail edges, and more, right? And so that automation, to your third point here, is absolutely critical. Any solution that you look at should have fully functional APIs to do everything that is required to deploy from the ground up. We have customers that are using Jenkins pipelines to deploy networking environments, then servers, then putting an OS on there, then moving into either putting Kubernetes directly on top of that OS, or putting on a virtualized environment. And then once they have that up and running, it goes that developers need consistent access, right? These things should automatically kickstart themselves. They should phone home and say, hey, I'm alive, I'm up, I'm ready. Give me the latest version of the code. download that, bootstrap into the apps, and then somebody can come in and configure that for the specific function that they're going to be using. So that complete automation process is huge, right? And speaking to that retail edge and the COVID thing, Bomsey, I was on a phone call last week with one of our customers where, they're a European retailer, 1,200 locations, and COVID came in and it hit hard for them. They had 70,000 employees. They had to reduce that staff by 50% for furloughing across all of Europe. And then what happened literally is, to use their words, is in 4 days, their web presence, because they were considered a critical resource, went from 10,000 transactions a day to over 100,000 transactions a day. I think they said about 114,000. And so that was huge. And then, they had to figure out, how do I scale my Kubernetes clusters at the appropriate locations to handle this new load? And then they had remote apps where they had to actually, then they had a fulfillment problem and they had to solve that. And, they worked through all these problems, but now they've become very much a online retailer, online business. So.
Pretty interesting, Peter. That was an interesting use case. Yep.
Yeah.
So thank you for that. Now, diving deeper into the technical challenges in architecting edge clouds. There's 6 ones that we can identify in these buckets. And what we do want to talk through is the Platform 9 approach to solving all 6. And you'll see that this isn't a proprietary approach. It's primarily based on open source software. Everything we do is out in the open source world. But it's also about operationalizing open source software, right? That's kind of where the secret sauce comes in. So the first problem is configuration management, right? So visualize an architecture where you've got thousands and thousands of servers, no matter, and I use the word server with respect, because a lot of times you can have a two CPU box that is running a given workload. But the ability to do configuration management, which means discovering new nodes as they're added in, which means finding out what inventory you've got running out there. And then as new nodes are brought in, configuring them to join the edge cloud, which means that not just are we talking about an operating system, but we're talking about a complete 3-tier application or 1-tier application that's running on Kubernetes. And then being able to deploy the business app itself on top of that, whether through an API or programmatically or through a click of a button or whatever have you. But the idea is to basically do this across the complete fleet, right? So you could have CPUs, typically, which you'll have some GPUs as well, and then to be able to do this at low latency, right? To be able to support requirements in telcos such as SR-IOV and DPDK, which all provide low latency kernel access for workloads, right? So again, configuration management is a key challenge that you'll run into day in and day out. Second is a workload mix. The reason why a lot of us at Platform 9 talk about the fact that the edge, in the way you're architecting it, in the way you're developing applications for it, should be no different from the core, is that you don't have to develop 2 different teams to do 2 different things, right? We all believe in the chassis model, where you build one chassis for your Accord, and then that gets transferred to the Lexus. That's what we believe in. So again, from a workload standpoint, you have to support bare metal because of low latency access, or the fact that Kubernetes itself provides you with multi-tenancy. You don't need to have a VM layer, another layer of abstraction and cost that needs to be managed and paid for. And then run containers on either or, right? Depending on application requirements. So again, what is the workload mix going to look like? Number 3, the overhead at each subcloud, right? This is a key point. So each of the edges itself is its own cloud. And if you've got 10,000 edges, we've seen implementations where people have 10,000 control planes. It's a complete cluster, because you're going to have such issues managing it, such issues upgrading it. You can't upgrade one part of the cloud without touching the others, impacting the others. So again, the ability to overcome this kind of a model and have a control plane which can basically be smart enough to partition itself or to be able to upgrade sub-regions. So given that each region maps to a cloud, is going to be key, right? And then, so Peter, any comments on the first three before I run through the last three that you have?
Yeah, configuration management is big, right? Operationalizing the, when you have a static edge or a retail edge or something like that, how are you going to do day two operations? How are you going to update Kubernetes when it comes out with a new release? Do you need to do that? I think that's huge, right? Supporting workloads, bare metals, VMs, orchestrations, containers, all have different application requirements. And how are you going to support a combination of virtualization at the edge and containers? I think that's a common problem. I think that the containerization and VMs are going to continue to live together for a long time, right? And we're going to have to plan for solutions that support both environments, and so be prepared for that.
Great.
So, yep.
Oh, thank you. So the last three kind of hit on the same themes, right? Number 4, lack of centralized management. So you want your management to be centralized so that you can basically make all and any changes from one central location, or maybe 2 central locations, and be able to lead to changes at each of the different edges. And then the simplified operations also include software management. How do you deploy applications to the edge? How do you make sure that DevOps pipelines are running and they're able to get the value out? And then finally, monitoring, right? You want to automate a lot of the monitoring, as well as automate a lot of the default management, right? Which is how do you do alarms? How do you tackle logs? And what do you do in terms of managing, virtual resources such as VMs and containers and networks, so on and so forth. So again, being able to do this alarm management itself is also key. So with this in mind, let's talk about, let's kind of break up some of these challenges and talk about some KPIs. So again, the key, how do you know your edge deployment has been successful? Again, I've done this slide a few presentations, we've done this, but again, I think it's key in terms of how you benchmark before and after the edge deployment. Number 1, the time taken to deploy each node, depending on hundreds to thousands to millions of edge devices. The scale, this is time to deploy the app on day 1 and then to upgrade the app to on day 2. The scale, what kind of scale are you supporting? Number 3, what kind of tenancy are you going to provide? Can developers log into this platform and make the changes they need to do and still not have to call an IT person? Number 4, how good are you with resource footprint right at the edge? So is your Kubernetes platform able to support really low latency use cases? And what does that look like? And number 5, flexibility of deployments, right? That we just spoke about. And then security as well. What does the security layer look like between the management plane and that devices? And then how do you do your model of remote troubleshooting and auto upgrades, right? Because when you talk about upgrading an app, you basically want to have a canary region, so to speak. That is something we're seeing more and more, where you don't want to touch the entire, all the edge sites. You do want to have a few experimental edge sites. Peter and his team worked at a massive North American retailer, virtually a household name. And the big use case was that they had 3 or 4 edge locations or stores, which were kind of their proving ground, right? So are you able to use things like service mesh technology to be able to perform app upgrades, and then only if they're successful and validated, do you roll them out to the different parts of the edge cloud and the edge ecosystem? So Peter, anything on these KPIs that you want to add?
No, I think we're going to touch on quite a bit of this in the next couple of slides. So let's jump forward and look at those.
Perfect.
So
yep.
Here's the first one, right? Simplified configuration management, right? Configuration management, what happens when you get a new node, when you bring it online? How do you configure the system the initial time? What happens when you want to upgrade Kubernetes? What happens when, a node dies and you need to add capacity in a very quick manner? So configuration management is absolutely important, as well as I think we're starting to see with a lot of the companies that we're talking to is this the concept of using commodity servers, right? Let's use the second generation stuff. Let's throw a Kubernetes cluster out there. Let's build it across all your old hardware and all your old servers. right? And continue to leverage that for a longer period of time. I think Kubernetes, even at the edge, allows you to do quite a lot of that stuff. And then, I think we mentioned this before, talking a little bit about the bare metal aspects of it, right? But being able to deploy once with one OS and maybe a virtualized environment on there today, and then tomorrow, all of your customers are moving to a containerized solution. And so once their apps are moved to containerized, now as an infrastructure kind of play at the edge, you need to be able to dynamically switch and support that new infrastructure. Right? And so what do? You have to reboot it? Do you send somebody out there? Do you put a CD in a server and then boot that server up? Or do you, take the automation approach, boot it to a brand new fresh OS, and then, configure it to the next standard, whatever that might be. And I think that's in a lot of cases going to be, we're going to start seeing Kubernetes as that standard. So, Vamsi, anything on this one?
Oh, sorry, speaking on mute. So no, just that bare metal is just catching up in popularity more and more. Every other customer I see wants to deploy on bare metal, and you should consider bare metal a first-class citizen of the edge, right? So again, yep, that's it.
Yeah, and we have customers doing actually bare metal at the edge, so it's kind of a very cool way of doing things. Bob, so you want to talk about the workload mix here?
Yep, so basically, applications should dictate the workload at the edge, not the other way around. So if your app needs a AR, VR type paradigm, you're going to have things like TensorFlow and other frameworks. You should be able to let the edge deploy the right profile of the server, the right memory, CPU characteristics, and then have the edge handle that no different from the way it handles a smaller server or a whole rack of servers, right? So again, with Kubernetes, you'll see a lot more of the cloud native application design out there. So again, from the app standpoint too, it doesn't matter if it's a monolithic two-tier app or if it's a container-based more modern app. You should be able to manage, monitor, track all of these from one central location. Peter, do you agree?
100% agree. Everything should be managed centrally. Everything should be managed with as much automation as possible, right? All the way from the metal, all the way up into the application stack, completely through automation. Popsy, are you?
So the management plane is fairly straightforward, right? There is one logical management plane you want to design for all your clouds, whether it's private or even in some cases, I would say public too. But that management plane should perform the function of providing self-service with different views. So if you have a developer team that is just concerned with publishing applications a certain part of the country, they should just be able to have the self-service to be able to log in, to be able to inventory their workloads, their servers they care about, and then to be able to cycle them, recycle them, whatever the hell they want to do, right? Do all of this manner because you want to keep the ask in terms of the the operations team as low as possible, and then everything should be done remotely. So the monitoring, security, troubleshooting, upgrades. Again, the idea is that a single management plane doesn't just mean a single pane of glass, but it also means that it's just one throat to choke, and to secure and to handle the failover and all that stuff across the life cycle of edge operations.
Yep, and it brings your operations staff into a single location, right? It brings your monitoring into a single location, and allows you to kind of manage that complete life cycle from a team that's not distributed across the United States or the world or the globe, right? So I think it's really important to think about that single management plane, doing everything from a consolidated place. And I think it's similar to what we were just talking about, centralize everything, right? And I just spoke to the shared visibility. But, the ability to know that my Kubernetes cluster at cell tower 1, 2, 3, 4 in New York City is having trouble, and being able to remotely fix that is absolutely critical, right? Setting thresholds, understanding your applications, monitoring for the appropriate things, is all absolutely critical. Tom, say anything you want to add on this one?
Yeah, just one thing about legacy too, right? If you've got VMware and other legacy technologies, you should be able to bring that in. So we never took the approach at Platform 9 that it was our way or the highway. If you've got existing VMware workloads, we're glad to manage them. And that's something that we take over to the edge as well. But the idea is that one of the things we come out of the box with is an ability to understand a bunch of common types in terms of what we monitor for. And again, glad to show you all a demo of that. But the idea is that, yeah, again, exactly, right? Simplified operations and not have you build snowflakes. Idea is that you got a tool chain that's fairly standard and you define it once and you can use it across every edge location. And then you could target specific regions, which are either a single data center or a single edge cloud or edge clouds in a country or in a certain state. And then do a bunch of batch operations that are idempotent, like upgrades, live migrations, so on and so forth. And finally, for developers, provide them with complete support for things like blueprints and templates, right? So Git is something we love in terms of GitOps and in terms of lifecycle management. We think of Git as not just a platform that does your storage of your code, but also stores the state of the infrastructure and then controls has this workflow like nature built in. And we've spoken about CI/CD pipelines and all of that in previous webinars. But the idea is that you have to have a way of setting these blueprints and these templates that are robust, that are standardized, and using a catalog, that is provided. Then we have an example there of the web page. Be able to use a single click to deploy to VMs or bare metal servers, and running containers as well. Peter, anything to add here?
Nope, I think you covered this one perfectly. Let's get to the last one.
Perfect. So the last point really is the alarm management and the logging as well.
I think we lost Vamsi. Or maybe it's me. Kamesh, can you hear anybody?
I can hear you. Keep going.
Okay.
Yeah. Can you hear me?
Yeah, we lost you for a second. You're back.
Sorry. Can you go to the next slide? Yeah. Sorry.
Okay. Did you want to? We lost the entire cluster level monitoring.
Okay.
All of
Sorry
that.
about that.
Reiterate.
So the last one is really Yep. Peter, why don't you do this? I'm going to join in from a different device. Is that okay?
Yeah, sounds good. So, Platform 9 offers monitoring centralized for every Kubernetes cluster that we do. It gives you a Prometheus, a Grafana interface to cluster level monitoring. So you get the idea of what's the health of my cluster? How many are all my nodes online? How's my CPU utilization going? Is my memory utilization okay? Right? All of this is pre-configured and available inside of that. Right? And then, we can configure our instances that are automatically deployed inside of Kubernetes clusters to do application monitoring, look at the health endpoints for, each of these applications that are running on there to see that they're healthy. And we put all of those metrics combined between cluster level monitoring and application level monitoring into a single place, not only for your individual cluster, but for clusters across the board, right? You have this for every Kubernetes cluster that you deploy. And another key aspect to fault monitoring and fault management is logging. And the logging is absolutely critical because whenever something starts breaking, the first thing that the developer says is, can I take a look at the logs? Can you pull me a log bundle, right? And how do you capture those? And if containers are spinning around, you need to have a solution for that. And Platform 9 offers a solution for log management with Fluent Bits and Loki. All right, so let's talk about the Platform 9 approach here, okay? I think we talked a lot about the challenges and some of the requirements for managing edge clouds, right? I believe that it's absolutely critical to have a SaaS type offering located in your centralized data center, right? So that way you can manage things from a single location. When there's trouble, you can have your ops teams call into a location and be able to resolve these troubles extremely quickly. Open source, you know, I think everybody gets the idea that open source is not free, right? And having a SaaS service that helps you implement open source tools is important, right? So, and then, you know, I think we mentioned this earlier too, let's leverage the hardware that we have, you know, and if you do have large groups of hardware that are available, and some of them might be older than others, right? You can leverage Kubernetes labels to say, hey, these are acceptable worker nodes for this type of application. But if you need something with a GPU in it, then maybe you need to, you know, label that node a little bit differently so that, you know, GPU type of workloads can be deployed there. Vamsi, are you back?
Yeah, I'm back, Peter. Can you hear me?
Yes, we can.
Okay. Now, just one point to add here is that when we look at this approach, it's a bit of a layered cake, right? In terms of all of the magic that we talk about in terms of the day one, the day two operational challenges, and day two plus stuff is all provided by the management layer. And I think beyond that, everything we do is in the realm of open source, pure open source. And incrementally, we're able to do a lot of the bottom certification with x86 infrastructure, things like GPUs, whatever have you. But you know, again, that's kind of being that heterogeneous edge platform. That's what we're turning into slowly. And I think when Peter talks about the architecture, that'll become very clear.
Okay, we should do a time check. We've got about 9 minutes, so I'm going to start speeding up to some of these slides for Vamsi.
Yep.
So I'll give you a quick introduction to Platform 9 in our SaaS offering, right? So what we provide is everything in that top box. We have a management plane that allows you to deploy OpenStack and or Kubernetes into locations that you may want to, right? They can be deployed on bare metal in the edge locations. If you've got VMware at the edge already, we can leverage that environment. If you've got bare OS environments, we can deploy it on there. We can deploy the OS for you, right? And then we can also deploy into various cloud control planes as well, Amazon, Microsoft, Azure, and Google. And so this user interface allows you to do all of that. It also gives you an API that can allow you to automate the deployment in any of the locations. So we're going to be there to do business where you want to do business. So, Vamsi, you want to talk about the ideal edge here?
Yeah, so this is the aspiration, right? What do you want to move to? Faster time to market, deploy apps in minutes, deploy edge locations in seconds even, reduce operational costs, not add to the people cost and the licensing cost of the software, provide you flexibility to run any kind of edge infrastructure, any kind of edge workload using a central plane, so you don't have the snowflake or silo situation. And then zero-touch edge operations, being able to do everything digitally, automatically, and then do everything centrally as well. But at the same time, not get logged in to the vendor in terms of how they work by leveraging pure upstream open source.
Awesome. So what Platform 9 does is it delivers to you what I like to call rock solid, production ready, either Kubernetes or OpenStack, right? When we talk about Kubernetes, it's upstream Kubernetes straight from the GitHub repo. It's not changed by Platform 9, offered to you as a SaaS managed service, right? Platform 9's monitoring technology and our alerts team. You know, think of our team as, so we've got your back. When we have a financially backed 24/7, 365 SLA to every Kubernetes cluster that we deploy. And if something breaks inside of that environment, think of Platform 9's team as somebody you can call. You can say, hey, we need to jump on a Zoom. We need to fix that problem. That's where Platform 9 exists, right? We've got built into our stack, complete automation, complete management, monitoring, maintenance. In fact, we've got the simplest zero-touch Kubernetes upgrade in the industry. Again, we're going to run where you want to do business, on the edge, in the cloud, in your local data centers, right? We're part of the Kubernetes security SIG that allows us to get access to Kubernetes vulnerabilities before they're released to the general public. Cool thing there is that we then can work with the community to build a patch, or we build our own patch, and then on day 0, we'll announce it to the public and what the fix is. And we will have PCI compliance for our certification, for our Kubernetes offering any day now. It was due like last week, so we should have it any time now. Okay, Vamsi, you want to run us through some conclusions here?
Yep. Very quickly, so we have a few minutes of questions. So first one is having a managed cloud at the edge will solve a lot of the complex infrastructure challenges, right? While saving you a lot of cost. So again, we invite you all to take a look at our management plane and drive a proof concept using that. All of this is going to be so easily apparent to you. In fact, we've got a free tier for anyone who wants to take Kubernetes up for a spin, where you could deploy Kubernetes on, everything from VMware to bare metal to OpenStack, whatever have you, or public cloud. And then we can automate a lot to reduce the human SRE cost of running the cloud. And then support the diversity you need in terms of your workloads, VMs, bare metal containers. And then finally, low touch operations. And at the same time, not be logged into a distribution or distributed version of Kubernetes, but, or have products that are open source in name only, in terms of how they wrap around Kubernetes, or they have their own teams that are developers committing to Kubernetes. But again, leverage open source, right? We are pure open source, and pure open source is mature, both in terms of OpenStack and Kubernetes, to do all the magic that we're talking about. Peter, any comments before we open up for questions?
No, I think we should jump right into questions. One of the questions I saw was, do you offer OpenStack inside of Kubernetes? We don't do that today. We don't run the control plane there. We manage the control plane for you. It sits in our cloud. So it alleviates you from the need to do that. And then the next question as a follow-up to that, do you offer OpenStack upgrades from major versions? And we do. At the time that I've been here, we moved up to Pike, into Rocky, and then we have some of our components now moving into Stein. So, yes, we schedule our upgrades with our customers at times that make sense for them. And, we provide the automation, the testing, and the upgrades of those environments frequently with zero downtime to the OpenStack environment. One of the other questions I saw here was, can you run Kubernetes on top of OpenStack? The answer is yes. We've got deep integration there, allowing the ease of creation and of Kubernetes clusters inside of an OpenStack environment. And I run Kubernetes clusters inside of that environment every single day. Kamesh, were there any other questions that I missed?
Yeah, there is a question about how to use old servers that don't support needed remote functions. We've noticed a lot of servers that aren't very old, but don't support all needed remote config operations. And many hardware providers are not in a hurry to support Redfish and such open source projects.
Yeah, we're starting to use Redfish more and more frequently with some of the bare metal deployments that we're using. We do that in combination with the ILO stuff that we're using. Redfish to give us some details about the server, the serial number, and things like that. And then from there we can track location. And then we use Platform9's Ironic offering, which is an OpenStack offering, to push the code to bare metal. We find that most hardware, as long as it's got an ILO card or equivalent in it, we can boot it up with bare metal. So.
And I think our remoting technology is all Platform9 agent based. So again, we'd have to understand what the idea is that we're able to do all of this at the level of the cloud, infrastructure as a service or platform as a service, using a Platform9 agent.
Okay.
Yeah, there's another question about OpenStack upgrades and whether we support all major versions.
We don't support all major versions. What we do is we try to stay N-1 or 2 from top of branch of OpenStack. We like to let the community break in OpenStack a little bit before we give it to our customers, because we offer an SLA around OpenStack. We have to ensure that it's going to work well. And so we test all of our upgrades, and we're usually N-1, N-2 from top of branch.
Awesome. I think we're almost out of time here. Just a minute. Are there any last minute questions? If you have any last minute questions, please feel free to ask. Otherwise, I'm ready to announce a winner for the prize. All right, today's prize, as we said earlier, NASA Apollo Saturn V. It's a cool Lego set. And the winner is Charlie Liu from Charter Communication. Congratulations. Charlie, we will reach out to you and get your mailing address and mail it out to you soon. Thanks for everyone for joining. Anything else you guys want to wrap up with?
So a lot of the stuff we spoke about, just book a Kubernetes demo or OpenStack demo with one of us or our teams, or just fill out the contact form. And there's a free managed Kubernetes service where you can basically see all the things we're saying about remote management, the single control plane, or the management plane, and how it does all the cool stuff in terms of the top 6 things every edge platform should look for. Again, we enjoyed being here, and from my side and Peter's side, thank you so much. Have a great day, and looking forward to you joining on the next webinar, which we have coming up here in a couple of weeks. With that in mind, thank you so much.
Thanks, everybody.